Good morning, ladies and gentlemen. My name is Zhang Kun Wang. This is my partner, Harrison Temperley, and we've been working on the project of optimization of a Cobot loading system as Team Hexagon. The CMM, coordinate measuring machine, is a Hexagon device that measures parts that are loaded into. Typically, these parts are manually loaded with high labor cost. With an automation system, this process can be much more efficient at a lower cost. However, a typical industrial robot is not safe for this type of close interaction, and they require high-skilled worker and programmer. Therefore, the introduction of collaborative robot is best suited for this type of human-robot interaction. Collaborative robot is much easier to program and safer to work around. We're pleased to say that we have achieved our best anticipated outcome and made few more adjustments to the system that made it even more robust. For our best anticipated outcome, we have created subroutines for the robot's operation, such as opening, closing the drawer, and loading and unloading part from the drawer to the CMM. We have created pre-compiled package that contains part information for us to create command. And finally, we have tested the overnight runtime capability for its final industrial purpose. For our key accomplishments, we have created subroutines on the teach pendant. After that, based on the pallet package information, we pass in variables to the PC DMIS, which will make it easier to program on the computer. Because we have to create subroutines, we have to tell the robot to do subroutines on different parts in different locations. We use many unique commands to send to the robot. As of that, we created an organized system that will compile and send this individual command to the robot for its operation. Last but not least, it is important that we use the robot gripper to detect whether a part is present or if it's the right part. If a wrong part is loaded onto the CMM, it can very well damage the system, or it could even harm the worker around the environment. Now I would like to pass to Harrison for more detail on the accomplishment.
So subroutines. Subroutines are the building blocks of our command. If you have a command to pick up a piece and put it on the measurement machine, you need to have subroutines to pick up the piece, a subroutine to move the part over, and a subroutine to put it on the measurement machine. Like function blocks, our subroutines also have input and output. Our input being our part type and location, and the output being picking up the part. These are very versatile subroutines. You can pick up from a table, you can pick up from the ceiling. You can place on any CMM around the robot. These subroutines are going to run 100,000 times. So it's very important, and we did our best, to make it as precise as possible. Commands. Commands are the bread and butter of our project. Every command is unique. So if you sat down with a robot and made a command for every part, you'd be there forever. What our system does is all you have to do is insert a data file, press a button, and our system will configure all the commands into a command sequence file and send it to the robot to execute. These commands this data file has part information, part location information, and the command sequence that your task requires. This allows the operator to run many different units, as well as run units overnight. Lastly, our system is very versatile. If a company will have custom tasks and require custom commands, our system allows the company to create a custom subroutine, and all they have to do is put that subroutine into the command to make their custom command. Next, we have a video showcasing commands and subroutines. As you see, we're actually not using the gripper to open the drawer. We have found when we use the gripper, there were oscillations within the drawer that caused air collision. So we used a rubber ball and socket method. And this is a open drawer pick part command. It's broken down into just two subroutines. The open drawer subroutine. As you can see, there's the ball and socket, and the pick piece subroutine. Very good. Part and error detection. If you're picking up 100 parts and you put a part in the CMM incorrectly, then every single other part you put into the CMM is going to fall off. This is absolutely disastrous, and error detection is absolutely mandatory. What we've done is we created subroutines to detect whether a part is there or not on pick or place. For pick, if the system knows that it's an inch wide and it picks up something that's half an inch wide, it knows there's not the correct orientation. For placing, when it places the piece, it grips again to see if it's in the right location and hasn't fallen off. If there's an error, the machine will stop and it will contact the operator. We'd like to thank everyone who has helped us with this capstone. Thank you very much.